Okay, distinguish between the electromotive force and potential difference. A cell of EMF E and internal resistance R is connected to resistor and resistance as shown. Okay, R as shown. So we have a battery here. This is a battery, and inside the battery we have internal resistance, small r, and we have a potential difference with V, voltmeter with V, and we have in the circuit we have a resistance with R, and this is a switch. Okay, number one, distinguish between the electromotive force and potential difference. So Shirian says that in the answer, electromotive force is the potential difference across the battery when there's no current is being drawn. I think this one you can get one answer. But when say that potential difference is the difference in battery potential between 2 points, this is I think this is not very detailed. Okay, so it can be have a 2 points. This is very easy, very general statement. Okay. Another way, if you want to answer this kind of what is EMF, first of all, EMF. Okay, EMF is a source in when you want to say in the concept of energy, EMF of a source. Okay, is the energy. Okay, per unit electrical electrical energy per unit charge supplied. Okay, it's the energy per unit electrical energy per unit charge supplied. This is when you want to talk about concept of energy in EMF. Another thing, if you want to say about the potential difference, potential difference is the for PD, I put as PD, potential difference is the energy change from electrical energy to uh, other forms to energy per unit charge. Okay, potential difference is the energy change from electrical energy to another to other forms to energy per unit charge. Okay, so it was let's say it's a work done because V equals to W over Q. So it says that change to electrical energy Q to another form such as energy W per unit charge. Okay. So B1 state whether the switch should be open or closed measuring the EMF. So you want to change, you want to measure the EMF, you have to open the switch. This is correct. You have to open the switch. And B2, the terminal difference is the terminal potential difference is closed. So you have to close the switch over here. Then you can find out how much is the potential difference between E and between A and B over here. Okay, that's correct. So one mark. One mark, one mark. Okay, do you have relation between E, V, and R and the current in the circuit? Okay, so I can see how can see clearly how we derive. Okay, but I show you how. E, another color. It's too much of red. Okay, so E equals to IR plus big R. Okay, so E and E also IR. So this is big IR. IR is plus with the V, voltage drops V, and so I equals to E minus V divided by R. So this one will be the answer. I equals to E minus V over R. Okay, so any question? So we have 3 marks over here, maybe 1 mark, 1, 2 and 3. 1, 1, 1. Okay, so we go to question number 17. Oh, it's raining over here. Two parameter plates are connected to a 120 volt battery as shown. Calculate the electric field intensity between the plates. And then the force of electron in between the plates and loss of electrical energy by the electron that's moved from plate A from plate B. So E equals to V over D. Remember actually when you start remember everyone, when you start the equation, you start with the symbol E equals to V over D, and then you put 120 divided by 0.02. So answer over here will be correct, will be 2 marks over there.
Yes, sir.
And F equals to QE, this is 1 mark. Okay, so it will be 9.6 times 10 power negative 16 Newton. Yeah, Newton. This one also correct. So 2 marks, full marks for that. Uh, and C, the loss in electrical potential energy. Uh, so loss potential equals to EV. Correct, is EV. So 160, 1.60 times with 10 power negative 19 and times 120. So you have 1.92 10 power negative 17. Okay, you have using another method, but answer is correct, so you consider as correct answer. Okay, so you have full marks of this one, 4 5 6 7 7 over 7. Okay, next we go to the question number 18. Okay, can you see the writing on the on the on the on the paper? Okay,
Can sir.
can or not?
Can, sir.
Can.
Can sir.
Okay, explain electrical conduction is measured in terms of motion of free electrons. Conduction is measured in terms of motion of electrons. State the estimate value of room temperature for means for okay. First of all, when the electric field is applied across the metal, the free electron will be accelerated to the same direction. Uh, yeah, this one is correct. They will be accelerating of the electron in the same direction. Okay. Okay, there are many atoms vibrating in the path of the motion of the E. Motion of the E. This is E. What is this? Electron. Is this electron? Uh, there are many paths vibrating, many atoms vibrating in the path of motion of the E. Actually, uh, why he wants to say that there will be a motion that is a atom that is vibrating up and down, but the E is going left and right. Okay, so I think he has to define, define or refine back uh, what he's saying about the second part over here. There are there are electrons collide with the atoms vibrating in the path of motion. This is saying back what is on the first the second point. Oh, it's a colliding. Okay, it says it's collide. Okay. After the collision, the E are again accelerated by the electric field and they continue to move in the same direction. Motion of the same direction produces the electric current. Okay. So, okay. I think there's no need for number 2 over here. This one no need. We just continue with number 3. And it says collide with the atom vibrating vibrating uh, in the motion after the collision again accelerated by the electric field. Okay, so it didn't say about the, it said about drift velocity. Okay, you have to say about the drift. So mention about drift velocity of the electron. Okay, because it was drifting towards the E, right? So let's say this is the E. This is a positive, positive, negative, negative. So electrons are drifting towards the positive part of the E, like electron. Okay. Oh, sorry. Electron is moving to the positive. Yeah, correct. It's a positive part because positive is a okay. The drift velocity. Yeah, you have to mention about drift velocity. Motion of E in the same direction produce electric current. This one also correct. Okay. Uh, so we go to number B. Actually, what it says is it says January is correct, but you have to define back number two, or I can say that number two no need in the answer. You just continue with point number three, and then you say there's the collision with the lattice vibration of the lattice item, and then there will be a drift velocity. The electron will be going the drift velocity, drifting towards a point of the E. Okay. Uh, then the current move in the direction of electric E. Okay. Number two. B A1, the mean speed of the free electrons. The mean speed of the electrons, okay, it should be around 10 power of 5, uh, 10 power of 5 into 10 power of 6 meter per second. Okay, and number two, a difficulty of flow with typical metal is around 10 power of negative 5 to 10 power of negative 4 meter per second. Okay. Next, given by the current density J equals to sigma E, where the sigma is electrical conductivity, E is electric field, show that is equivalent to Ohm's law. So 18b, it says that you're using J I over A and E V over L. This one correct. Okay. A, then you have J, A constant, L is constant, and this is sigma is sigma is constant. So J is direct proportional to E, V is direct proportional to L. Okay, so you have uh, V to I. J is direct proportional to E, and V is direct proportional to I. V is equivalent to Ohm's law. Okay, let's try this one, another method. Okay, J equals to I over A, and E equals to V over L. Okay, substitute this one into J over sigma E. Okay, so you have I over A equals to sigma V over L, and V over I, that is the Ohm's law, V over I equals to L over sigma A, and this will be a constant. Okay, so it's a proof that equivalent to Ohm's law. The whole thing over here is a R. Okay, this is R, this is R, and this is R, constant. Okay. Uh, Next part, C. Uh, A fire of length is 1.10 meter, cross-sectional area 1.5 millimeter, carries a current 40 ampere. When potential difference 0.3 is applied across the wire. Calculate the drift velocity of the free electrons in the number of free electrons if, okay. So I equals to Navi, and answer is correct over here, 1.919 times 10 power negative 4 uh, meter per second. What is the force of each electron? Force of each electron will be force of each electron will be, answer is wrong over here. Okay, so this one is not the answer. Answer is F equals to E, QE. QE or EE equals to V over L. So 1.60 times 10 power of negative 19 and times with E, 0.30 divided by 1.10. So you have 4.36 times 10 power of negative 20 Newton. That will be the force of each electron. Why is using T? Okay, second. So answer will be 4.36 times 10 power negative 20 Newton. Okay, that is the answer number 2. Okay, number 3. Calculate the resistivity of the material of the wire. So, resistivity of the wire. So, yeah, you can use V equals IR, rho equals to RA over L. Then you have 1.02 times 10 power negative 7 ohm per meter. So this one correct. Two marks over here. Okay. So this is the answer for 18. Okay. Next class tomorrow. Is it Hankit? Right. Hankit is it? Who's going to do number 19?
Hankit.
Hankit. Okay. So by tomorrow, Hankit, tomorrow morning you have to pass up question number 19. So we discuss in the Zoom. Okay. We already have that 20, but of course we have to continue from 18, 19, and 20. Right. So that's it. Okay, so tomorrow we discuss about 19 and 20.
Okay,
Mostly,
thank you,
Okay,
sir.
sir.
mostly what Sheridan has done is correct. Okay, maybe
Yay.
80% of the answer he gave is correct. Okay,
Fantastic.
so see you tomorrow. Okay,
Bye,
bye bye.
sir. Thank you, sir.
Okay.